So we look at another sample question on geometric progression. So this came also in the ECZ exam. So it says in a geometric progression, the third term, so they're telling us the third term. Remember what we said, meaning that when n is equal to 3, the term in the third position is a 2/9. And they tell you, and the fourth term is 2/7, meaning that when n is equal to 4, the term in that fourth position is simply a 2/27. Then they tell you find the first term and the common ratio. So you apply the general form. Remember, AR raised to the power n minus 1 should be equal to Tn. Of course, you can start with Tn is equal to AR raised to n minus 1. There's no problem. So we just replace there. So we are going to come up with two equations, then you solve them. So here, I'll replace in AR n minus 1 is equal to Tn. So my first term I don't know, my common ratio I don't know. My n is a 3 minus 1, which should be equal to 2/9. So therefore it will be AR 3 minus 1 will give me a 2, which is equal to 2/9. This is going to be my first equation. Then again, I can apply the same formula and substitute that. The first term I don't know, my common ratio I don't know, my n is a 4 minus 1 should be equal to 2/27. So it will be AR raised to the power 3, that's 4 minus 1, should be equal to 2/27. This is going to be my second equation. Now, in most cases, when you have this, you need to solve them simultaneously. So the way I'd love to advise you is that when you are solving such a mathematical problem, look at this one. It says AR raised to the power 3, then this is AR raised to the power 2. So you can get this is a bigger one, you divide by the smaller one. So it is going to be, you get equation 2, AR raised to the power 3 is equal to 2/27. You divide, let me use a different, you divide by the first equation, so it will be AR raised to the power 2 over 2/9. So that's the way it is. So this is equation 2, and I've divided that by equation 1. So that's what we do. Then you will work out, you can reduce this and that will cancel. Here there are 2R. If you cancel the 2R and you cancel the 2R, you just remain with a single R. Now if you look at this one, it is the same as 2/27 divided by 2/9. So don't get confused. Remember, 2/27, when you change the division to multiplication sign, this goes up, the denominator goes up, the numerator comes down. So it will be 9/2. 2 there, 1, 2 there, 1, 9 there, 1, 9 there will be 3. So therefore, to be 1 times 1 is a 1, 3 times 1 will be a 3. Or you can use a calculator directly. So the common ratio there is simply going to give you simply just a 1/3. So that's the way we can simply go about that. It's very simple, not complicated. Now once you find your common ratio there, you can now take any of the equations to find the first term. For example, I'll get the simplest one there, I'll get the simplest one there, so meaning it will be AR raised to the power 2 is equal to 2/9. Remember, my R is a 1/3, so it will be 8 times 1/3 raised to the power 2 will be equal to 2/9. It will be 8 times, remember that will give you 1/9 is equal to 2/9. Now what you can do there is that, of course, you can divide by 1/9, but the simplest is you multiply by the reciprocal of 1/9. What is the reciprocal of 1/9? It is simply 9/1. What you do this side, you also do it the other side. So this and that will cancel. You are going to remain with A is equal to, remember, 9 there, 1, 9 there, 1, 2 times 1 will give you a 2, 1 times 1 will give you 1, 1 into 2 will give you a 2. So you can see what we mean there. So therefore my first term is a 2 and my common ratio is a 1/3. So that's the way you can go about that, right? With that in mind, let's move on to the B part there. Let's move on to the B part there with that concept in mind that we have. The B part there says that find the sum of the first 5 terms of the geometric progression. So we want to find the sum. Remember, we know the first term is equal to a 2. The common ratio, we know it's a 1 over 3. Of course, 1 over 3, if you divide it, it is going to give you the same as 0.333. It's a recurring number. So how do you find the formula for the sum? Of course, the formula that you apply would be A. It would be 1 minus r raised to the power n over 1 minus r. Why use this formula? Because our r is actually less than 1. So when your r is less than 1, you simply apply that one. So it is going to be Sn is equal to, what is our first term in the sequence? It's a 2, and it will be 1 minus my common ratio 1 over 3, but this raised to n. What is my n? Sorry, my n, since it says the first 5 term, meaning that your n is equal to 5, so there it will be a 5, so raised to the power 5. Let me just try to differentiate by using this type of brackets, over 1 minus 1 over 3 there. So you just need to work out and do some mathematical gymnastic there. So if you want, you can work out that and simply say 1 minus, open bracket, 1 over 3, close bracket. So you can simply close the bracket, then you raise this guy to the power 5. So what is that going to give you? So if you notice what that is going to give you, I've worked out all that stuff. It is simply giving me, so this is going to be 2 multiplied by 0.996. I've left it to 3 significant figures. Then 1 minus 1 over 3, it is giving me a 2 over 3. I can take it to a decimal number. That is going to give me a 0.667. So what is that going to give you? So I can say 2 multiplied by 0.996. The answer I get, I divide by 0.667. And what is the value that I'm getting there? I'm simply getting a 2.99. So that is the sum of the first 5 terms there. This is what they wanted you to do. Of course, be careful as you try to work out that. Then the C part there says that we find the sum to infinity. Now remember, the sum to infinity is equal to the first term over 1 minus the common ratio. So therefore, the sum to infinity will be equal to the first term is simply a 2 over 1 minus 1 over 3. So it will be 2 over, if you subtract there 1 minus 1 over 3, that will give you a 2 over 3. And therefore my sum to infinity, if you say 2 divided by 2 over 3, it's the same as just a 3 there. So this is what you're going to have. That is the sum to your infinity. So that is what the question wanted you to do. Please, you need to do more practice work, and that is really going to help you when it comes to geometric progressions of this nature. Thank you so much for watching.